vocabulary, of course, you will hear solutions, roots, all means the same thing. They're the values that make the equation true. Some textbooks even refer to those as zeros. Zeros, solutions, roots, all kind of synonymous. Solving the equation, of course, we're going to solve it. And then equivalent equations, two equations with the exact same solution. So if you end up two different equations, x equals 2, we say the equations are equivalent, for whatever that is worth. Okay, so properties of equality. You know all of this. So when we start solving these linear equations, of course, if you add something to the left, you must add something to the right. You have to balance. Whatever you do to one side, you do to the other side. You have to multiply by 5 on the right, you have to multiply by 5 on the left. So you know that, whatever you do to one side, do to the other. Okay, linear equations. Those are the easiest, because we probably going to spend the least amount of time on them, because these all have a degree of 1. So these are all x to the first is what we're talking about. A little dramatic there. So of course this would be super easy to solve. So would this one. Yeah, you got a half in there, but we can deal with a fraction. Same with that bottom one. So the first type we're going to solve are the linears. Very basic, very straightforward, maybe some fractions. Then we're going to get into some of these. A quadratic with the squared. There's where our factoring might come into play. Some square roots, and what we call a rational equation. Rational, remember, fancy name for a fraction. So, I'm sure you can solve the first one. I just kind of giggle. You can solve the first one without me. Oh man. So let's get the x's on the same side. I'm going to subtract 3x from the right, so I'm going to balance and subtract it from the left. So my 4x minus 4. And I feel pretty confident you could take it from there. We're going to add 4 to each side. So we're up to 12. And without further ado, x is 3. Don't you wish every problem could be this easy? Now, we should, of course, talk about, you know, if you're worried about if your answer is right. I mean, this one's right. We all know it's right. Don't forget, if you're on a quiz or test, you can always check your answer. Plug 3 back in and make sure you get the same value on each side. Don't forget about that. I know we tend to not check, but just a little reminder. Now, you are going to have some of these crazy equations, still linear on here because we're solving for that big capital M, which is m to the first. Now, more variables, same deal though. I'm trying to get the capital M by itself. Well, whenever we have a fraction, I don't love that over r squared either. You probably don't either. Let's clear the fraction. So I'm going to multiply by r squared on the right, which of course I'm going to sneak it in here and do it on the left. So let me write the left a little prettier, r squared f. So on the right-hand side, we've got the capital G, I've got the little m, and the capital M. So last thing we're going to do, we need to get the capital M alone. So I'm recognizing there's product between all of those, the G and the little m. So what I'm going to do, of course, is cancel it with division. So I need to divide a capital G and a lowercase m on. So looks a little crazy, but we do have capital M alone. That was our goal. I'm just going to write down all of this stuff. R squared f, capital G, little m. So you will see maybe one of the differences, Algebra 1, probably forgot all that good stuff. You will see some more where you have to solve for the specified variables. Let's practice another one. Solve for W. Okay, all right. Now this time, we got to be a little creative because I see W is in 2 terms. So let's first just get those 2 terms together. And this is, that's not a 1, that's an L. It's 2LW. Is what that is. It looks like a 1 to me, but whatever. Okay, I'm going to get the W's alone, so I'm going to get rid of this 2LH. I'm going to subtract it. Trying to write neat here. 2LW. Okay. So first, just get the terms of W by themselves. So little extra work on this one because you do have W in 2 terms versus just a single one like the previous problem. So just when you least expect it, we're going to factor. I can factor a W out. Now I know I could factor a 2 out also of here, but remember, we're trying to pull W out. I just want to have plain old W. So I'm going to factor just the W out. So I'm going to have the 2, the L, the 2, and an H. I know you can technically do it too, but I'm trying to isolate W. I'm going to fill in all of this. I'm like, okay, I can get W alone. W looks like, of course, product, the distributor. I'm going to cancel product with division. So I'm going to divide off 2L plus 2H. So that's gone. We've got W by itself. I'm running out of room. I'm just going to circle it. So a little crazy with all the letters. Definitely a step up from the last one. So just to recap, you had W in two terms, so I left those on a side by themselves. Took the W out, I factored it out. Thank you. And then, of course, I divided off what was in parentheses. So just think of your inverse operations. What do you need to do to cancel? Okay, D, still linear, x to the first, but fractions. Now, two ways you can go about it. You can just roll with the fractions. Be like, okay, yeah, I got my calculator. I can deal with 2/5 and 3/10. If, because I know some of you absolutely hate fractions more than life themselves, you could multiply 5, 10, 5, 10. You can multiply everything by 10. That would cancel out the fractions. The least common multiple, fancy vocab, of 5 and 10 is 10. So I'm going to multiply everything by 10 for those that hate the fractions. Okay, 5 goes into 10, 2 times 2, that would be 4. 10 times 1, 10 times 3/10, and 10 times 3. This is an equivalent equation. We will get the same answer, but that's maybe a little easier for them to solve. Let's subtract 3x over. We can handle it. Let's add 10 while we're at it. So I've got x equals 40. You will get the same thing if you left the fractions in there. It's totally up to you how you want to play it. I know some of you hate fractions. Okay, that is the exciting as it gets for the linear equation. So just plain, boring, basic, standard ones, couple crazy variables, and you play the fractions how you want. Now, quadratics. Lots of methods, techniques to solve quadratics. Remember, quadratics have a degree of 2. Squared, okay? So this is where all this fun stuff on the board comes into play. I'm going to try to factor always first if I can pick my method, just because factoring is the easiest and it takes the least amount of work. But of course, not everything does factor. You can't always figure out what multiplies to whatever and adds to the middle. It just doesn't happen. That's why we have completing the square and quadratic formula. Now, we're going to use our zero product property. That's a little times in there, little times. So of course, if you're multiplying, we're just going to set each of those equal to 0. So I know it looks crazy with the letters. Let me give you something that's more concrete. I guarantee if I said solve this, x is what? Yeah. You just set each factor to 0 and solve for x in your head. You're technically using the zero product property, even though you might not necessarily say that every time to yourself. All right, let's solve it. Of course, first things first, I'm going to set it to 0. Let's subtract 24 over. Now, factoring, of course, we can factor that all day long. No GCF, always think about a GCF. Don't have one. What multiplies to negative 24 and adds to 5? Gosh, I love this one. Nice and easy. We get to review factoring. You've got the answers. Let's just put them down, negative 8 and 3. Love it. Okay, same thing. I'm going to set it to 0 first. I'm going to be conscientious of the order because I want that 11x, but I'm going to move it to the left so it becomes a negative. I need that in the middle. So of course I always check for a GCF first. 2, 11, 6. Nope, don't have one. Okay. Lots of ways to factor this. Some of you like to guess and check it. I'm completely fine with that, especially with a 2. I mean, you don't have a lot of choice. It's going to be 2x and x there. And then you can try to unfoil it in your head and do the numbers. Go ahead and do it if you like it. Or if you like more of the process, you can multiply your outside 2 numbers. Figure out what multiplies to negative 12 adds to negative 11. And then divide these both by 2. So I'm going to have x minus 6, 2x plus 1. Whatever you're going to do to get your factors. All right, 2 solutions. What fine fraction answer is your first one? Negative 1/2 fraction. And of course, 6. So good, good. We got to review factoring. We did a lot of factoring last week. Factoring keeps coming up over and over and over. So again, nothing too crazy so far. Some linear equations, some fractions in them, a little bit of factoring. This isn't awful either, okay? Solving a simple quadratic equation. Now, simple, okay, that's pretty simple. Here's the deal. You don't have a trinomial. You don't have an x term in it. So I'm not like, oh gosh, I gotta set it to 0 and factor. No. I'm gonna get x alone super easy. What cancels squaring? Square root. I'm just gonna root it. Squared, 2 answers. Now, because we love radicals in here, I'm always gonna ask, can I simplify the square root of 5? Nope, it's prime. Okay, good. I always got to check. If it was the square root of 8, of course I would. Okay, again, first glance, I always have some poor kid that wants to like FOIL this out and do all this work, and I'm like, no. Get rid of squaring with a root. Don't forget your plus or minus. We just talked about square root of 5. We're not going to talk about it again. But you have one little extra step. To get x alone, we're just going to add 4 over. So when we get to completing the square, that's what we're leading you up to, which might be the one new kind of thing I have for you today. Your equations are going to end up kind of in this form, where you're going to have this quantity squared and a number. You're going to have a lot of answers in this style when we get to our completing the square. That's what we're working our way up to, basically, completing the square. Okay, so if you can't factor, then your choices are completing the square or quadratic formula. So we're going to do completing the square first. Now, first up, you have to make sure your lead coefficient is a 1. So notice for dramatic emphasis over here, I put just a generic a in front, and you can see I'm dividing it off. You have to make sure your lead coefficient's always a 1. Then, you are going to do half a b is the middle term, and you square that. Now, doing that calculation, half of b, and squaring it, when you put that on both sides of your equation, it now has forced your trinomial to factor. That's what we're trying to do. We're trying to force these problems to be factorable. That is the whole purpose here of completing the square. So this I'm going to go through kind of slow because I don't know if you did much of this in Algebra 1. I'm guessing none in geometry. So I just want to make sure we have this down. Now, I couldn't factor on it even if I wanted. Nothing multiplies to 13 and adds to -8. It doesn't happen. So first things first, I'm going to move 13 over to the other side and just get it out of the way. I'm also, on purpose, I'm going to leave some space here because we're going to recalculate a third term so it is a trinomial. So leave a little room, subtract 13. So we are going to recalculate this third term. And of course, whatever I add to the left, we add to the right. Now to figure out the third term, a little mental math here. Notice I was nice. We started with a 1. I didn't have to worry about that. We're going to do half of b. b is the middle coefficient, 8. So half of 8. I know you can do that in your head. I'm just writing it out for the first one. And then we're going to square that. Well, what's 4 squared? 16. So I did half of 8, and then I squared it. Now the reason why the left now factors. What two numbers multiply to 16 and add to -8? -4, -4. And I'm going to just quickly, I'm going to write it in this style. Remember I said this is prepping you for completing the square. I'm going to write it x minus 4 squared, and we'll finish solving it that style. Okay, so x minus 4 squared. We're going to add up -13 and 16. I'm going to get rid of squaring with a root. I'm going to remember my plus or minus because we have 2 answers. We're solving a second degree equation. And last but not least, let's add the 4 over. Got it. So this might be, they might do it a little bit in Algebra 1, but it's been so long you might be a little rusty on it. So that's why we're going to do a couple of these just to practice. Quadratic formula is easy. Okay. I don't like the order about this. It's kind of a hot mess. First thing I'm going to do, let's just add 14m over. I'm going to put that in the middle. Got it. All right. So nice thing about b, of course, lead coefficient is a 1. I don't have to worry about that. Now, I could not factor this even, we're not factoring. I know there are numbers that multiply to negative 72 and add to 14, but they want completing the square. So that's what I'm going to do. I'm going to move 72 over. I'm going to leave some room here on purpose. On purpose. I'm going to go the same color. Let's do blue here. Now, on the first one, of course, I wrote out half of 8 squared. I don't expect you to do that. You can mental math this. We're going to do half of 14, which is 7, and now you square that. What's 7 squared? Got it. The reason we have the 49, the left factors into that perfect square. Multiply to 49, add to 14, 7 and 7. I hear you guys adding up the right side. What's 72 plus 49? 1. What do you got? Add them up. That's kind of nice. I kind of like that. Kind of a big number, but I kind of like it. What's significant about 121? Perfect square, yeah. Okay, so this is going to be nice. Okay, root it. Plus or minus, because we're doing a second degree equation, 2 answers. Square root of 121. And then I'm going to subtract 7 off. Okay, now because we have a nice perfect square under our root, I can get you 2 distinct answers. Negative 7 plus 11, negative 7 minus 11. Okay, question for you. Since I had those very lovely, nice answers this time, do you think our original equation could have factored? Yeah. Multiply to this, add to this, 18 and negative 4, okay? But here's why I tortured you with this. A, it said completing the square, so we're practicing completing the square. But B, just to show you, there are other methods you can do and get the same answer, but of course this is more time consuming. That's why I have up there factor first. You can factor it as way, way faster than going through any other method. But, we're practicing completing the square, so here we are. All right, let's do one more. I don't like C. We got a little twist on C. What's your lead coefficient? Hey, okay. We got to get rid of that first. That's the easy little detail that's very easy to forget, that one. Lead coefficient has to be a 1, completing the square. Rest of the methods, it doesn't matter. All right, 12 over 3. 6 over 3, 0 over anything. Now, let's just talk about it quick before we get carried away. If I had a choice, could I factor this? No, I can't multiply to 2 and add to negative 4. Okay, so we're going to move the 2 over. We're going to recalculate that third term so we can force that left side to be factorable. All right, half of 4, let's mental math it, half of 4 squared. And notice one other thing, just to point out in case anybody's wondering. Notice I said half of 4, like I'm ignoring the fact that it's negative, because I really don't care. Because whenever you square something, it always turns out what? Positive. So that's why I'm ignoring the sign, because I'm squaring. I know it's going to be a plus, so I don't even waste the effort on it. Okay, there's my scale. Multiply to 4, add to negative 4, negative 2, negative 2. We're going to add that up. We're going to get rid of squaring, of course, with a square root. We're going to remember our plus and minus for our 2 solutions. A little quick mental check. Does the square root of 2 simplify? Nope, prime, but we always got to think about it. Last but not least, I'm going to put the final answer up here. I'm running out of room. Add 2 over. Okay. Does completing the square look vaguely familiar at all or no? Some yes, some no. Okay, so this, like I said, is probably the only new thing I have to show you. Okay, the last thing last method. I think you know this one. Quadratic formula. Now, of course, there's pros and cons to all the methods, okay? So factor first. I can't say that enough. That's always the easiest. If it doesn't factor, then if I have a choice, I'm like, do I complete the square or do I use the formula? Generally, I find completing the square quick if your b term's even, because it's easy to do half of an even number and square it. If I have big numbers, they're all crazy, I'm not going to worry. I'm just going to plug it into quadratic formula and be done with it. Okay, so hopefully we all know this. Do we know the song for it? Let's pause the. We didn't need to record it. Okay, all I have to say really to do these problems, my spiel, make sure you're in the correct order, squared x number. If you have really big numbers in the equation, maybe see if you could reduce them down. This is my pro tips. Now, I am going to show you this. This is going to be fun. We are going to do this. It's going to be a humdinger. But we're going to just do some basic quadratic formula problems first. So flip the page for now. We're going to come back to that. That's just a for fun thing on your notes. But let's go through quadratic formula. All right, as you can see, my terms are in the correct order, which is winning. I'll tell you this. There's no way I would complete the square on this if I had a choice. Because I'd have to divide by 3. It'd be a truckload of fractions. I'd have to have a fraction. I'd have to square it. It'd be really time consuming. Let's just put it in quadratic formula. X equals the opposite of b. So notice I put positive 5 plus or minus the square root. Now you can put negative 5 squared. I find that obnoxious. Negative 5 squared minus 4 times a times c all over 2a 2 times 3. So in your calculators, and I'll punch it in, I've got the online calculator up and ready if we need it. Straight, literally type in 25 minus 4 times 3 times negative 1. See what you get. Tested the calculator skills. Because I swear, half the time I have kids that will set it up perfect and something happens weird on the calculator. What lovely, here's a hint. Prime number did you get? 37. Because you really have 25 plus 12 there. Okay, before I circle it, I always check. Can I simplify the square root of 37? No, I kind of gave that right away when I said it was prime. There we go. So does this look familiar? Have you done quadratic formula? Okay, let's do it. All right, so again, same thing. I'm going to first check that my terms are in the correct order. They are. 4, 12, and 9, I mean, kind of big, but not crazy. Is there a common factor in 4, 12, and 9? No, I wish there was. If there was, I would divide it off and work on smaller numbers. It's always easier. There's not, so I'm just plugging them in. X equals the opposite of b, plus or minus the square root. B squared, 12 squared, I'm just going to roll with 144, minus 4 times a times c, all over 2a, 2 times 4. So let's type in what's underneath the square root. That has a very lovely little fancy name, by the way, called the discriminant. In case you wanted to know that, I'm sure you did. This is a good one. What do you have under the square root? 0. Don't let that scare you. 0 is a number. What's the square root of 0? 0. So ignore that. And if we left that on a quiz, I'd say minus a half. Because it's not simplified. What does it simplify down to? Okay, question though. Aren't we supposed to have 2 answers? Yes, no, yes, no. First question, are we supposed to have 2 answers? Yes. Do we?
No. The value is greater.
Technically,
Negative 12 minus 0 is still.
we technically have 2 answers. They're just both the same. Because the negative 12 plus 0 is negative 12. Negative 12 minus 0 is negative 12. We technically have 2 answers. They're both the same. Do you need to write it twice? No, but just recognize we do have 2 answers. They're just both the same. All right, let's do one more, then we're going to back it up and do that fun problem, little funzo problem. Okay, last one. If you had a choice, does it factor? No, okay. This one might be a good one, though, if I had a choice to complete the square on, because I'm like, oh, yeah, I could do half of 2 and square that quick in my head. But they want quadratic formula, so okay, I'll do it. Plus, I know you like to hear me say it. Opposite of b. B squared, 2 squared, minus 4 times a times c. Over 2a, 2 times 1. I'm already concerned. What's 4? We don't need a calculator. What's 4 minus 8? Uh-oh. Can you do the square root of negative 4? No. So this does not have a, get ready for it, real solution. This kicks it into the imaginary unit system, which we're going to study in another section coming at us. For us, for right now, we're just going to say no. If you just write no solution, I'm happy. But I'm going to be particular. I'm going to say no real solution. That's how we're going to roll. We will tomorrow do imaginary units, and we would write that as 2i. Get ready for that. Okay, back up the truck. The last thing I'm going to show you. God, this is so great. Are you ready for it? Now, here's the thing, my friends. Quadratic formula. Where does it come from? It is not just some formula some old crazy man made up to torture math students. It is a manipulation of our standard general quadratic equation up here. So if I said, hey, complete the square on this. All right, I could do it all day long. First things first, I need this to be a 1. So I'm going to divide off the a. I'm going to write it over here a little prettier. So I got my x squared, my b over ax, my c over a, and 0 over anything. Now, we're going to complete the square on it. So just like all the previous problems, I'm going to move c over a to the other side. Looks crazy, but it's the same process. Leave some room, leave some room, leave some room. And I'm going to subtract c over a. So just like most of the other ones, let's do it in blue. Now, to figure out what you're going to add, same deal. I have to do half of this coefficient. Oh, Lord. We get to review multiplying fractions. This is the problem that has it all, my friends. So b over 2a. Okay. Then we're going to square it. Oh, good. We get to practice exponent properties. I'm going to square everything. b squared 4a squared. Looks crazy. I know. Okay. Now, as crazy as this looks, the left-hand side does actually factor. There are expressions that multiply to that and add to b over a. And that brings me to my next little trickarooski that I wanted to show you. If you're like, ever have fractions and you're completing the square problem, you're like, oh my God, I can't figure this out. It's always whatever half of b is. Half of negative 4. There you go. Half of negative 8. Negative 4. Half of 14. 7. So it's always that half of b. We'll get to it here. So I'm going to factor this. It's what you got when you did half of this. So b over 2a. If you FOIL that all out, you'll get this. Now, the right side lets us practice adding fractions. God, it's got it all today. I need a common denominator here, okay? So we got a squared. I could throw another a on here. That's no biggie. And this dude's got a 4, so I also need a 4. So I'm going to put 4a on. Kind of a hot mess there. I'm going to write that as negative 4ac. My b squared and my common denominator. Oh, good. We just got to also now practice adding rational expressions. This problem has it all. It's great. Okay, I'm going to get rid of squaring. This is so good. It's so good. I'm going to remember my plus or minus. Now, this, I'm just going to reverse it. I'm going to put the b squared first. Oh, that's looking familiar. what do you get when you square root the bottom? What's the square root of 4? Square root of a squared. Oh, it's quadratic formula coming at us. Check it out. Last things we have to do, of course, is subtract this b over 2a. Opposite of b. Interesting. And of course, since your denominators are the same, when we do the formula, we just put it all over 2a. Look at that. That's so neat. So all you have to do is complete the square on your generic quadratic equation, and that's how quadratic formula comes about. Not something some old man just pulled out of his you-know-what to torture math kids. And hey, we got to practice some factoring, some rational expressions. We got to do it all, okay? Any questions on that? I can tell you're not